Ooh, right.
Yeah, of course it is. 970 fucking C. So aerogel is really itchy material. You don't want to really get any on you or your clothes because it's just really super itchy. So this is a 10 millimeter thick material here. We're gonna add 2 layers of this to the furnace. It is like Satan's butthole in this suit. I've covered the furnace in 2 layers of insulation. So I've wrapped it with this foil here, which will keep the dust contained. Kind of poke this ceramic tube through the outside there for the thermocouple, crossing 448, 854, 1126 degrees C. That's all she's got. She ain't got no more on the transformer. 1175 C. Not bad. All right, 1185 C. Woo, we're looking super toasty. Yeah, giddy up. That is hot, hot, hot. Very good. So this thing peaked at 1185 or so, and it's quite hot in there. And so I just turned off the power and letting it dead drop down now, just to see how well this insulation works. $980C on the cool down. Definitely holds heat fairly well. Guess I'm losing most of it out the door there. All right, so I've propped my aerogel up against the door of the oven here to just kind of cover it up, and I'm heating up now. I'm heating up really slowly, so I'm only at 40 degrees C. Put a piece of pottery inside the oven and to be fired, so that's why I'm heating up slowly, because I don't want it to explode. So I wasn't able to cross 1200 degrees with my elements in series. So I've now changed the wiring on my elements. I know it's kind of difficult to make out, but I've changed the wiring to have the elements in parallel. So parallel allows me to run higher current, 21.6 amps, which is putting each heater element just over 10 amps per heater element, 75 volts. So 21 times 75 means I'm definitely over 1500 watts. Cooled down a little bit from my temperature that I was at, so I could do the wiring. So now I'm just heating back up to get across the finish line. All right, looks like we have reached 1200 degrees in the oven. So wiring in parallel definitely worked and got the extra power it needed. All the way cooled down, and kind of interesting thing, my pottery that I was firing is let's see if I could make a crucible for melting some aluminum. And the really interesting thing is that the floor of it had all these little chips, these loose chips in the bottom that kind of had popped loose. And I had it sitting on this bit of aluminum fiber insulation on the floor of the furnace. So I'm wondering if that had a part to play in it happening. I'll have to ask somebody a little bit more experienced at firing pottery, but I know that you don't put these right in the kiln sometimes, that they can go wrong. But this looks good and fired, so I'll have to test it out now and see how well it works on melting some aluminum. So I'll be wearing better shoes for that experiment. On the heating elements, you can see that white formation because they're aluminum ferrite heating elements, and the aluminum actually forms an oxide layer on the surface protecting the element. So the elements are in really good looking shape. So that's pretty encouraging.